for people to trickle in. So get started in just a moment. Welcome back, everyone, to our Totem Top 10 series. This is our series on basic cybersecurity hygiene. We've talked about a lot of things so far, and I hope you're enjoying this series. I've certainly had an awesome time, and I'm looking forward to the next several weeks together and what we're going to be discussing in the coming weeks. But today, our session, or our topic rather, is on patching software and operating systems. This is a crucial component of a cybersecurity program, and I think it's one that people assume they know more about than they actually do, or maybe they assume that they're doing more than they actually are. And so today we're going to highlight a number of different things concerning this control. We're going to talk about how unpatched old pieces of software or operating systems that we allow to run inside our environments present us with a significant cybersecurity risk. And hackers love to take advantage and exploit these systems. And so we're going to talk about just the danger sort of we're all currently faced with. I am then going to launch into another live demonstration where I'm going to actually show you an example of how a hacker may exploit an unpatched system. So I'm really looking forward to that demonstration, and hoping that everything runs smoothly. We had decent luck last week, so we'll see how it goes today. And then we'll wrap up the session with just a discussion on how patching fits into your cybersecurity program, what sort of cadence you can expect to establish in terms of how often you should be patching, what you should be patching, and also what other sorts of things you should be doing after implementing patches. Simply applying a patch is not the only thing to do with this step. There's more to be done than simply applying patches. So really looking forward to this. We're going to be using a number of different tools today, which I will explain as we go. But this is going to be an awesome session, one I've definitely been looking forward to for several weeks now. As always, if you have any questions or comments, stick them in the chat. I am monitoring it, and I will be happy to answer any questions you may have. My name is Nathan. If you're tuning in for the first time, I am a cybersecurity engineer with Totem Technologies, and we are so excited to be doing this series for Ohio SBDC, and we've had a great time so far. And so I appreciate you all tuning in today and taking the time to learn a little bit about cybersecurity. It's awesome. So feel free to reach out to me. My contact information is there on the screen if you want to talk about any of this stuff more, or you can connect with me on LinkedIn. I'd be happy to discuss more. As always, a quick review before we jump into the presentation. A couple themes that we have discussed in detail over the last 4 weeks. First is that small businesses are indeed prime targets for hackers. We have, over the years, sort of built up this mindset that we are not favorable targets of hackers because we are small businesses, because we don't have the resources, the wealth that maybe a large business would have. And although there is some truth to this, we debunked that myth by showing that small businesses are actually key targets of hackers because our cybersecurity is the weakest of the bunch. We've talked about how our users typically are not trained to be able to identify and protect against even basic cyber threats like phishing, which gives adversaries a great opportunity to exploit that weakness. We've also talked about how our systems tend to be not secure, not up to par to where they should be. We may be relying on old or outdated software or operating systems to go about our day-to-day operations. And so as a result of all these different weaknesses, hackers love to target small businesses. And we are seeing more and more and more small businesses getting just absolutely hammered by cyber attacks every single year. It's been a disturbing trend that has been increasing upward. And so we need to do something about it, which is why I'm so glad you all have tuned into this, because that's what we're trying to address with this series. We've talked extensively also about how if you were to boil cybersecurity down to one thing, it would be risk management. With all the threats, all the vulnerabilities out there facing us, there's just way too much to try to protect ourselves against all of them. It would be way too expensive. We as small businesses don't have the resources to dedicate to trying to prevent every single threat out there. And just cybersecurity aside, like trying to eliminate all risk just isn't really feasible. So instead, we're going to take the risk management approach, doing what we can to mitigate our risk instead of trying to eliminate it. And what this looks like in terms of cybersecurity, we found, is taking what's called a defense in depth approach to our cybersecurity, which basically means instead of relying upon, one really fancy, really effective piece of technology or another process or something, we instead layer multiple different safeguards together. And with these safeguards working together, we are able to lower our cybersecurity risk, because in the event that one safeguard does not work in preventing a given threat, another one is able to step in and take its place. And so throughout the course of this series, we have talked a lot about different controls that contribute to our defense in depth strategy. And to give a little bit of context as to how these controls work, we have gone over a phishing example, a real phishing attack that we received several years ago. I sort of demoed the attack on the first day. We looked at what sorts of nastiness would have occurred had a user clicked on that invoice.doc there on the screen. And so throughout this series, to sort of help us understand how to apply each of these controls, we've looked at each one sort of through the lens of this simulation that we ran through, and okay, what would this control have done to help us prevent this phishing email from being successful? And so we will continue that trend this week as we explore patching. But last week we talked about software whitelisting. And this is our first technology of the series. We've spent most of our time talking about more policy or user training related ideas. But last week we kicked off with our very first technology. And as you may recall, software whitelisting is without a doubt the single most powerful technology that you can put into your environment, because it allows you the capability of controlling exactly what software you want to run inside your environment. Because essentially, whitelisting, being the opposite of blacklisting, takes the approach of deny everything by exception, deny everything by default and only allow by exception. And so what that means is we would specify exactly the software we want to run, and everything else is denied by default. And so to help us understand this, I presented the example of a wedding, and how a wedding is a very controlled environment. You don't want, the wedding crashers to show up and ruin the show. So you control who is allowed to attend your wedding. And by doing that, you send out wedding invitations and RSVPs and whatnot. The idea is very similar when it comes to whitelisting. It's another tool in our disposal, another tool as a part of our defense in depth strategy that we can use to control the software running in our environment. And this helps protect against malware execution. It helps protect against unknown programs being installed. And it's really just a nice sort of safety net to help catch anything that may try to slip through any of our other controls. And so super powerful technology. We recommend you consider software whitelisting. Well, this is where we stand so far in our series. We have covered 3 controls so far, as I mentioned: know your assets, train your users, and whitelist software. By the way, I recently put up a blog on our website talking all about the very first control, know your assets. So this is our cybersecurity blog page. I don't know if you've had a chance to visit our website yet, but this is just another helpful resource. I'm sticking the link in the chat to our blog. We talk a lot about just everything cybersecurity within the DoD realm, within the private business space. I mean, we cover a lot of stuff in this blog, and so there's hopefully some helpful information in here for you. But I recently published a blog specifically on know your assets. So if session 1 felt like information overload, feel free to go check out that blog. It goes into detail pretty much everything we discussed during the workshop and then some. So check out that blog. My colleague Matt recently published a cybersecurity threat modeling for small businesses blog to help folks identify what threats are out there, to identify which ones are important, looking at it through the risk management lens. And so he went super in depth in this blog as well. So check any of that out. We've got tons and tons of blogs, just pages of them, and we publish pretty regularly. So it's really just a great place to keep up to date with the cybersecurity landscape too, if you don't already have a blog that you're following, but feel free to check that out. Anyways, this is where we stand in the series, and today we're going to be talking about patching. So let's go ahead and dive into the discussion. I don't see any questions. Feel free to type any questions in the chat if you have any, as always. But I'd like to start by just discussing where the need for patching even originates. We know that the software and the operating systems that we have running on our computers, on our machines, are incredibly complex. They are the combination of many, many different processes, different lines of code, different functions, all working together to create a highly complicated product. Okay. Do we have any software developers on the call right now? I'm sure they can vouch just how insanely complex building this stuff is. I've tried it, and it's a headache sometimes, because all the different things that go into it, and all the different components you're trying to get to work together. Consequently, as a result of its complexity, mistakes in software and in operating systems do happen. Errors are made unintentionally during creation, and usually it isn't until after this software or operating system has been deployed, has been released, that these errors are discovered. And unfortunately for us, in some cases, these errors do turn out to be catastrophic, as they are exactly what adversaries are looking for and using as a means for their attacks, for carrying out their malicious activities. And so it's a huge risk just to even have it. It's a risk. Thankfully, though, just because a piece of software or an operating system has been deployed into our environment or put out into the public does not mean that corrections can no longer be made. what vendors will do is they will develop and release something that's known as a patch. A patch, the most basic definition, basically being just any set of changes to a given system that are designed to update, to fix, or maybe to improve that system. When we talk about patching in the context of cybersecurity, we're usually talking about a patch addressing some sort of vulnerability or some sort of error or issue within the system. But patches could also include like feature updates, maybe to improve the usability of a given program to make it more user-friendly, to add new features or whatnot. So patching is a broad definition. There are many different things that a patch could address, but specifically in the context of this series, when I talk about patching, I'm primarily talking about a patch fixing errors within a given system. So that's sort of how we're going to view it. And as I mentioned, the responsibility of patching does fall upon the developer of the piece of software or the program. You are not responsible for actually writing the patches. If you're using some third-party software, that responsibility falls upon them. And honestly, we should expect as consumers that those we are purchasing software from are releasing patches regularly. So if you are paying for a software or a program or whatever, and you're unsure if patches are even being released for it, I would recommend that you look into this right away and ask them what their patching schedule is. If they don't do patching, turn for the hills and run, get rid of that product because it has instantly become your biggest risk. If during your investigation you come across some terms such as end of life, this is a term that indicates that the product or the piece of software is no longer being supported and therefore patches are no longer being released. So if you're looking up a software that you use and you're on their website and it says this product has reached its end of life, unfortunately, that means you should proceed to uninstall it promptly, because since patches are no longer being released, it instantly becomes a risk, like I said. So, and hackers are actually looking for this sort of stuff. They will actively seek out popular pieces of software that have reached their end of life, and then they automatically know that this is a pretty much instant successful exploitation method, because they know exactly the state of the given piece of software as it is the vendor is no longer updating it, no longer changing anything with it. And so they can easily craft new attacks, share among their fellow hackers, and create some ugliness. So like I said before, though, keep in mind that just because a vendor is still supporting a given system does not mean that you don't have to actively manage it within your organization. And what I mean by that is, although the responsibility of creating a patch falls upon the vendor, it's ultimately our responsibility as consumers to ensure that we are staying up to date on the latest patches, we're staying up to date on the latest vulnerabilities that are affecting our systems. That is our responsibility. And we should understand that the longer that we go without doing this, the greater risk we are putting upon ourselves. So think back to our first discussion of the series when we talked about Know Your Assets, and how the very first step in building a cybersecurity program is to gather a complete IT system inventory, all of the hardware, the software, the sensitive information that is flowing throughout your environment. The truth is, as we talked about, you cannot fix or you cannot patch what you don't know exists. And so we need a system inventory. We need something to manage all this information. because the longer that our IT assets go without us knowing that they're there, without us managing them, the more dangerous that they become. And so, in fact, like I sort of touched on a moment ago, one trend that we have noticed is that hackers will actually wait for a patch to be released, typically for an operating system, but they may target an application as well. They'll wait for a patch to be released and then proceed to go out and find devices that actually don't have that patch applied yet, because they know exactly what vulnerabilities the patch is addressing, because it will describe that in the documentation published by the vendor. They'll describe exactly what vulnerabilities. They won't usually go into super deep detail, but they'll at least give a basic overview of what vulnerabilities the patch is addressing. And so hackers will seek this out, this information, and then actively target machines that do not have that patch applied, because then they will know, oh, they have these vulnerabilities I see right here. And so this is ultimately what has unfortunately allowed attacks like ransomware to spread like wildfire, is vendors releasing patches and us as consumers just not applying them, not doing anything with them. And so hackers way too easily having the information that they need to begin crafting their attacks and begin exploiting these systems. So we're almost making it too easy for them. So it's a huge concern. It should be a huge concern for us, and it should cause us to question what sorts of things we are currently doing to implement patches in our environment and ensure that we are staying up to date on the latest security updates with our software and with our operating systems. So I'd like to now spend some time as we transition into our demonstration, showing you all an example just of the sorts of freedoms that we give hackers when we don't patch our stuff, and just how ugly it can be. I'd like to run through a hacking demonstration that where I'm actually going to be exploiting an actual vulnerability that caused some serious concern for a lot of people back in 2017. And it's actually what has, unfortunately, sort of set forth the chain of events that have led to the ransomware crisis that we are in today. And the vulnerability that I will be exploiting is known as Eternal Blue. It's a crazy story with this. Actually, Eternal Blue was originally developed by the National Security Agency, and it was developed as an exploitation tool. They use it for intelligence gathering and counterterrorism efforts. And so they created this tool to gather information from the bad guys. And basically this tool, this exploit, targeted a specific protocol within Windows operating systems known as the server message block, or SMB, which is essentially a file sharing protocol. And they discovered a pretty severe vulnerability within this protocol. And so they proceeded to not tell Microsoft, and they developed a tool to exploit this and use it against their enemies. Well, they did this for 5 years until they alerted Microsoft what they were doing. And Microsoft immediately labeled and created an official vulnerability for this deficiency. They labeled it MS17-010, MS1710. But ultimately, it didn't really matter, because shortly after this, the NSA got hacked, believe it or not, and Eternal Blue ended up being leaked to the world. And this was cause for serious concern, because this tool was developed to be an extremely powerful hacking tool, And the NSA kept it to themselves for years. And guess what? It just became published to the entire world. So super terrifying. And although Microsoft did immediately release an emergency patch addressing this vulnerability, there were still millions of devices left with the patch yet to be installed. And so, as I mentioned, this sort of set forth a chain of events that has allowed ransomware to become the monster that it is today. Once hackers realized how easy it was to exploit Eternal Blue, they took this tool and they used it. They combined it with a ransomware worm known as WannaCry, and this worm, basically what it would do would on its own, so it would infect a target system, and then on its own, it would search for other nearby devices that were also vulnerable to Eternal Blue, and then it would infect them with the exact same ransomware. And so it would spread really, really, really fast. And so, as you can imagine, it blew up. It went global really fast. Eventually, like 300,000 systems in over 150 countries were impacted in total. I think millions, probably billions, I don't actually know the number, of dollars in Bitcoin were forked over to adversaries because this is what they demanded in exchange for the files which they would encrypt. And even though they would demand payments in exchange for decrypting files, there was no guarantee that they actually would decrypt the files. And so it was just a really ugly situation all around. Lots and lots of people were affected by this. And ultimately, those affected were those who did not have that emergency Microsoft patch installed. And I don't blame them. They didn't have much time to do so. But it was really, really unfortunate just how this whole situation sort of transpired. And so we can take this and use it as a learning experience for us today. Unfortunately for me to say that, but it's what it is. And so what do you think? Shall we see this exploit in action? I think yes. However, as we did last week, we must pause for a moment and recognize what exactly we are trying to do here. I am attempting another live demonstration, and this is the easiest way to achieve failure and embarrassment. So let's just pause for a moment and offer our petitions to the live demo gods or whoever that this would be a smooth demonstration. And if you would, feel free to add your supplications into the chat if you wish to contribute. But I think that's good. I seemed to have found favor last week. Didn't have really any major issues. A couple hiccups, but all right. I think we're good to go. Before we begin, another quick note. Please know that everything that I'm going to show you is being done inside a sandbox environment, meaning it's all purely a test environment, and it is also purely for educational purposes. The tools that I'm going to show you should not, of course, be used on actual systems, as that would become illegal. So don't try to go hack your coworker's computer after watching this, okay? So with that out of the way, I can't hack like this. I need to get into the right mindset. So I'm going to transition here. Get into my appropriate hacker mood. I look so silly. All right. With this being said, I would now like to take you all through the mind of a hacker. I'm going to pull up our tools. Our target for this session is John. And John is a very busy man. He runs his own company. He does financial consulting. And one day, John decides to take a trip to his local Starbucks to enjoy some coffee and get some work done. So he signs on to the guest Wi-Fi, and away he goes, minding his own business. Now, one thing to know about John is John also does not really like change. He has been using Windows 7 for years and does not plan on changing to a newer operating system anytime soon. It's what he's used forever, and he's going to keep it that way. Well, unfortunately for John, he is not the only one who is connected to this Starbucks network. And John is about to get hit with a very, very heavy dose of hacker. And so I have two virtual machines here. I have a Kali Linux machine and I have a Windows 7 machine. Our target, John, is the Windows 7 machine. So this is his computer. My background went away. Let's make this a little nicer. There we go. This is John's machine. This is what he's working on inside of Starbucks. As you can see, he has a work folder here. He has an administrative folder where he actually stores his passwords. Obviously, don't do that, but John is doing that. And then he has a folder also labeled projects where he keeps all of his client information and everything he's working on in the form of text documents. And so this is what John's machine looks like. We are going to be using another tool called Kali Linux as our means for exploiting John's machine. Kali is a specific Linux distribution, and it was actually developed for ethical hackers, for the good guys who will go in and identify deficiencies within your system, weaknesses, areas of attack, and basically just put on the hacker persona like I'm doing so effectively right now, and identify potential exploits within a given system. So it's also known as pen testing. You may have heard that before, but this is what we're going to be using. So step one, if I'm the hacker and I'm running my Kali Linux machine, is once I've connected to the Starbucks network, I want to see who else is connected. And so I'm going to open up a terminal where I can execute different commands. And I'm going to run a command that will allow me to see what other devices are on this network. And I'm going to run the scan. It shouldn't take long, super fast. This scan returned 4 IP addresses. Just since I'm a hacker and I have some knowledge, my understanding of networking, I know that these 2 IP addresses, 192.168.152.1 and .2, probably aren't other machines on the network, or they probably aren't what I'm looking for. So that leaves me with 2 options, either 192.168.152.128 or 136. Well, I know that my IP address is 136. So that means that 128 is the only one that's left. In this case, that's John's machine, but we're going to do some more digging. This is what we call the information gathering stage. So next thing that I need to do is I need to see what exactly, what type of operating system John is running so that I can know how to exploit it. I'm going to run this command. Targeting John's machine. Oh, got to do it in sudo. Rookie mistake. 192.168.152.128. My password, because I'm running this command with what's known as sudo or root privileges. And so I need to provide my password in order for that command to be run. Okay, lots of information here. I just want to point out the most important stuff here. So first off, I can see all the different open ports that are running on this machine. That's important. I'll come back to that in a sec. Another important piece of information is I can see that this machine is running a Windows 7 operating system. This should, as a hacker, this should immediately raise my eyebrow and get me a little excited, because I know that Windows 7 machines are very outdated and they've reached their end of life, so they're no longer being supported. And so it's likely I can find a way to exploit this machine. Okay, so we see that, and then we also see a lot of different open ports which are important. I mentioned a moment ago that part of the Eternal Blue exploit was it targeted a file sharing protocol in Windows operating systems known as server message block. Well, I know that the server message block protocol runs over port 445. So the fact that I see that this port is open, meaning that it is utilizing that service, also makes me think this machine may be vulnerable to this attack. So let's find out for sure. I'm going to fire up MSF console. This is the tool that we're going to be using to actually exploit the system. This was, again, also created for ethical hackers. What we're going to do is we're actually going to search for MS17-010. Remember, that is the official title that Microsoft assigned to the Eternal Blue vulnerability. So we're just going to search for that. And preloaded into this console, into this tool, are a bunch of different things that we can test. Well, all I want to know is, okay, is this machine vulnerable to Eternal Blue? That's all I want to know. So I'm going to use, let's see, I'm going to use 4. No, 3, excuse me. I'm going to use 3. This is going to tell me if this machine is indeed vulnerable. Port, got to do some configuration here. I'm going to run. Okay. Well, I can see from the scan that the target machine, John's machine, is likely vulnerable to MS1710, to the Eternal Blue exploit. So that's awesome. Let's go try it. Search again. Type correctly. I know, just because I've done this before, that the specific exploit we want to use is the first one. It defaults to a specific payload. We don't need to get into the details of what that means, but this is basically what contains all of the scripts and all the technical stuff that actually makes the attack work. So super in the weeds, we won't get into that. I'm now going to identify my target. I know John's IP address, so I'm going to set that in. Identify. Remember that we identified when we ran the initial scan that his port 445 is open, and we saw that it was running server message block. So we're going to set 445 as our target port. Make sure everything's configured okay. Yep, looks good to go. Cross your fingers. We are now going to attempt this exploit live. Let's see how it does. That's going to be weird, of course. Well, that's okay. I planned ahead. Let's close out of this. Actually, I'm just going to open up a new one. Fire up MSF console again. Take a moment. Live demonstrations, guys. They're a risk. All right. Seems it closed out on me, so we'll try and run it again. Yeah, it's unfortunate. This doesn't work. Make sure I can still ping it. Ah, that's why. That's why my Windows 7 machine died. Let's fire it back up. John turned his laptop off. That's what that means. Yeah, he had to get up to go get his coffee. All right. Now I should be able to ping it. There it is. Perfect. Try this again. Awesome. As you can see, target is vulnerable. Excellent. Win. As you can see, the exploit worked. And what this means, there's a lot of information there. Basically, what this means is we targeted John's machine with the Eternal Blue exploit, and we used it to effectively gain control of his machine. That's what this means. Let me show you. As you can see, users directory, I'm just changing folders right now. I am within his system right now. And I see John right there. Let's move into the John directory. Let's move to his desktop. There's his work folder. Remember that? There are his administrative and projects folders as well. Oh, there's his passwords.txt. Definitely going to want that. Back. Projects. I know I'm typing at 1,000,000 miles an hour. And there are his client documents. So we have successfully exploited John's machine. We have successfully hacked John's machine. And so this is where we can start to do some serious damage. This tool has lots of features built into it for ethical hackers to really understand what weaknesses a system might have. And these are all the different things that we could do. We're not going to be doing all of this, but some scary stuff is I can create directories, I can create files, I can download files, I can upload files to the target system. I can shut down the system if I want. I can reboot it. I can get system privileges. Let's see, where's that? EUID, get system to somewhere else. I can install a keylogger on his machine. Remember when we talked about a keylogger? So basically anything that John types into his machine, I can see, including passwords or whatever. I can even take a snapshot from his webcam. I can play a video stream from his webcam. I can start a video chat. I can take a screenshot. So for example, say John's, stop changing his desktop. This one's way nicer. Say John is in Notepad and he's He's typing something. I want to see exactly what he's doing. What I could do is I could pull up a live feed of John's machine, but that is most certainly going to crash all of this during the presentation. So I'm just going to take a screenshot. Screenshot saved. Let's go find it. There it is. In addition to that, let's get back over. I could create a malicious document and then upload it to his machine. Say I went to his projects folder and I created a document called client-1, and then I uploaded it to his machine, except it's Zoom bar just gets in the way. I could create a malicious document, name it client-1, and then upload it to his machine where he may not be able to even tell the difference. Remember when we were talking about whitelisting according to names? That would be one reason that you maybe would not want to do that, because as an adversary, I could see, oh, he's got this client-1 document. I'm going to create a fake document, give it the same title, and I'm going to upload it in its place and remove the other one. And so John's going to go click on it, and the whitelist is going to let it through if it's whitelisting according to names. So ultimately, I could talk for a long time about all the different features in this tool, but I think I've made my point. Ultimately, this exploit was made possible because, well, two reasons. First, John connected to a public open network that you should never do. Second, he is running an old and outdated operating system on his computer, one that has already had a multitude of exploits published online, and so the information is easy. I learned how to do this online from Google, right? So any hacker could do the same. So it should be reason for concern, and it should make us want to ensure that we are patching our stuff. So we get out of my hacker persona. Back to presenter Nathan. But I hope that was of some value to you. If we have more time, there's so much we could explore with this tool and with this exploit, but I wanted to show you that. Let's go ahead and take a look now at, as we start to wrap this guy up. Let's take a look at how patching should actually fit into your cybersecurity program. So the first thing that we want to do is we want to establish some sort of cadence for when we want to install these patches. Installing them right away is a cybersecurity best practice. So that would mean installing automatic updates. And that is what we're going to recommend as well for all applications and all workstations. You turn these guys to apply patches automatically. There are ways that your IT staff can actually configure all of your machines to apply operating system updates automatically when they're released. Windows patches are released the second Tuesday of every month. This is also known as Patch Tuesday. And so the second Tuesday of every month, you can create a group policy that will impact all of your machines and apply Windows patches at the end of the day when your users shut down their computers, because hopefully they're doing that. Definitely do not forget to patch everything else. This includes like your servers, your firewalls, your camera systems, anything else you might have if you have a random IoT device on your network, like a thermostat or a refrigerator, whatever. Make sure that you're patching these guys as well. It's an excellent thing that we have a system inventory that will help us manage all this information, right? It's it's a good thing you have that, right? If not, definitely get that in place right away. There are just way too many devices in the average environment to be able to remember everything and stay on top of everything. So get a system inventory in place to be able to manage patches and all other system inventory information. NIST provides some guidance on patch management. The specific framework is NIST 800-40 if you want to go read up on that. I'll just reiterate this since I already talked about this earlier, but always inquire about a patching plan before you purchase any new software or whatever. It should be one of the questions that you're asking during the testing phase or whatever as you're investigating a given product. Be sure to ask about that and ensure that the vendor is applying patches consistently to help protect you, because you are trusting them by putting their product into your environment. And so ensure that they're applying patches regularly. And finally, and it's a shame I'm going to not spend much time talking about this, because this is one of the most important things that I will say this morning. You must follow up each patch cycle with routine vulnerability scans. This is how you're going to ensure that patches are actually being applied and taken. You can use a vulnerability scanner. There are plenty out there. The first one that comes to mind is Nessus. It's probably the most well-known vulnerability scanner. And you can use it to essentially just scan your system, and it will identify deficiencies within the system. I'll quickly show you how Nessus works here in a second. I do have some time. But if you do choose to partner with a managed security service provider or MSSP, they may have a tool as part of their SIM that will have a vulnerability scanning capability. Ours does, and actually that's one of my responsibilities here, is to run regular vulnerability scans after Patch Tuesday to ensure that patches are actually being applied. Please be sure to do that. Let me show you Nessus real quick. We'll jump back into Kali, since this is the easiest way for me to show you. Go up real fast. Okay. Nessus is running. Firefox chance to boot. Fire up Nessus. Please do not take a long time to compile plugins, Nessus. Just take a screenshot. Looks like it's almost done though. Any questions as this is firing up? I hope I haven't lost anyone on this wild journey we've been on today. There are lots of different ways you can spin up Nessus. It doesn't have to be in a virtual machine. It doesn't have to be in Kali Linux. Lots of different ways that you can use Nessus. This is going to take forever. I'll bring it back up if it finishes, but Nessus, super useful tool. Find a vulnerability scanning capability out there that best suits your organization. Well, with that, brings us to the end of our presentation. I did want to touch real quick on how this control, as you think through questions, feel free to type them in the chat. How would this control have helped us during the Hawkeye phishing attack that we looked at on day one? And it's pretty simple, actually. If we had had the latest Windows security patch installed in that instance, the vulnerability within the equation editor, you may remember, in Word would not have been an issue, would have been remediated. And so quite simply, the attack wouldn't have worked because Microsoft had already released a patch for it. And so it didn't affect us. So pretty easy way of addressing that vulnerability. In some cases, hackers are still able to get around patches, which is why we still need our defense in depth strategy. We need other controls in place to protect us from attacks, since a patch may not do everything that we need. Any questions as we close out our session today? We went over a lot. I threw a lot of technical information at you, but I hope you can see the value when it comes to patching, especially through a live exploitation on site. It wasn't super exciting. It would have been better if we'd had some hacking music. So darn it, but hope that was beneficial to you. Any questions? Comments, concerns? Did you enjoy the demo? All right, man, quiet group today. That's just fine. Well, thank you all for joining us. I had a blast. We'll see you next week as we talk about restricting administrative privileges, another technology that we can introduce to our environment. Thank you all for joining, and feel free to get in touch with me if you have any questions. See you next week.